All right, let's practice some of the problems that we've talked about. I'm going to start off first of all by breaking it down into some of the different categories of factoring, and then we'll try to put it all together. Number 2, 16x minus 24. What would be the largest number that I can divide 16 and 24 by? That's going to be 8. Am I going to be able to take out an x in this problem? No, because 24 does not have that variable. So the only thing I'm going to be able to do is to factor out an 8. So I'm going to write the GCF on the outside. What I'm technically doing is I'm dividing both sides by 8, and let's see what I have left. 16 divided by 8 is 2x. Negative 24 divided by 8 is negative 3. Keep in mind that I can always check my answer by going back and distributing. 8 times 2x is 16x. 8 times negative 3 is minus 24. I should get exactly what I started with. Again, that's just the check. My answer is 8 times 2x minus 3. If we look at number 6, you'll see that I'm going to find the GCF between 6, 18, and 12. The largest number that I can factor by 6, 18, and 12 is 6. I notice here that I have an x in common with each of my terms. I have an x to the fourth, an x to the third, and an x squared. So you're going to see that I can take an x out. You can only take the smallest exponent that you see out. So the smallest exponent between 4, 3, and 2 is 2. So my GCF is 6x squared. I'm going to write it, and then I'm going to take my GCF and I'm going to divide every term by 6x squared. Now, as you go through, you might not need to show that step, but I'm just wanted to show you exactly what I'm doing. So my 6's are going to cancel out. X to the fourth divided by x squared, we're going to subtract those exponents. 4 minus 2 is 2. 18 divided by 6 is 3. X to the third divided by x squared is x. Plus 12 divided by 6 is 2. And then I'm going to factor this on down. All right, so they've asked us just to factor out the greatest common factor. So I'm going to stop there, but as we go on into different types of problems, we're going to check to make sure it can't be factored further. If you look at number 10, this looks a little bit different. But what you're going to see, and this is sort of a hint that I can give you, is if you have a parentheses in your problem, the first thing you want to look at to see if those things inside your parentheses are the same. And in this case, they are. That means that my GCF is actually a binomial. So I'm going to write my greatest common factor. Remember my slogan, write it and divide it. I'm going to take each factor and I'm going to divide it by that GCF. So in the first term, the 2x plus 5s are going to cancel out. It leaves me with x squared. And in the second term, the x plus 5s cancel out, and it leaves me with 17. So 2x plus 5 times x squared plus 17. The next type that we're going to talk about is to factor by grouping. Remember, the factor by grouping is only when we have 4 terms. So if you look at 12 just to check, if I was doing this problem from start, I would look at all 4 terms and I would see, is there a number that I could factor out of all 4 terms? In this case, there is no GCF. So I'm going to group the first 2 together and I'm going to group the last 2 together. And I'm going to look for the greatest common factor out of every term. I can see that x to the second is the GCF of my first set. So again, what I'm doing, I'm writing it and dividing it. X to the third divided by x squared is x minus 3, because my x squareds are going to cancel out. In my second grouping, the GCF between 4x and 12 is 4. So I'm going to divide each factor by 4. So 4x divided by 4 is going to give me just x. 12 divided by 4, carrying my sign, I'm going to get 3. Again, remember what I told you earlier about the grouping problems. I want to have left inside each binomial the exact same thing. And in this case, I do. So I'm going to factor out the x minus 3. I'm writing the GCF. Here's what I'm technically doing. I'm dividing each term by my GCF of x minus 3, and I'm going to write what I have left, x squared plus 4. The last example on the factor by grouping is I've chosen one that has a negative on the third term. Remember, that can get you in a lot of trouble with your signs. This grouping problem does not have a greatest common factor that I can factor out of all 4 terms, but I would be sure to check that. I'm going to group the first 2 terms. Remember what we do when our third term is negative. I'm going to include the negative inside the parentheses, and I have to put a plus between those. If I don't put a plus, I've changed that problem to multiplication, and we definitely don't want to do that. So now we're going to look for a GCF out of the first grouping. The GCF between x cubed and 6x squared is x to the second. Remember, I'm going to factor out x and the smallest exponent. So I'm going to divide both of the terms by my GCF. X cubed divided by x squared is x, plus these are going to cancel out and give me 6. On the second grouping, when you've included the negative, you always want to factor out the negative as part of your GCF. So negative, the GCF between 2x and 12 is 2. So I'm going to divide both of those terms by negative 2. Negative 2 divided by negative 2 is going to give me positive x. Negative 12 divided by negative 2 is positive 6. I again have what I need. I have the same thing inside the binomial, so I'm going to factor that out. So I'm going to write it. Basically, I am dividing each of these terms by x plus 6. You can put it in parentheses if you want to. You write what you have left. We have x squared minus 2. Okay? Now we're going to talk about factoring trinomials. Trinomials is when I have 3 terms. Looking at 18, I do not have a GCF in that problem. I've counted my terms, 1, 2, 3. I have 3 terms. So I'm going to start off with 2 binomials. I'm going to plug in my sign. If the third term is positive, you look to the left. They're both going to be whatever that sign is. Then we're going to break up x squared. X squared breaks up into x times x. Now, to finish it up, we're going to find out what 2 numbers multiplies together to give me my last term of 15, and it's positive 15, and adds together to give me my middle term of 8x, or in this case 8. What 2 number multiplies together to give me 15, but adds together to give me 8? That would be 5 and 3. If you do the full method, first, outside, inside, and last, and I add my like terms together, you'll see that I get exactly what I started with. But the easy trinomials will always work this way. You'll be able to fill in your signs, what multiplies together to give you your last term, and adds together to give you your middle term. Let's see if we can work another example. This does not have a GCF. It's a trinomial. I start off with my two binomials. The third term tells me my signs. So when my third term is negative, it's 1 plus and 1 negative. All right, so x squared breaks down into x times x, and I want to know what two numbers multiplies together to give me my last term of negative 5 and adds together to give me my middle term of negative 4. Notice that I already have my signs. One has to be negative, one has to be positive. Well, there's only one way that I can multiply together to get negative 5. It's going to be 5 and 1. So I know that one has to be positive and one has to be negative. So since I'm trying to get a negative 4, the 5 is going to be negative and the 1 positive. So I can put with the negative, whichever binomial I put the negative with, the 5 goes with the negative and the 1 goes with the positive. Again, if you full this out, you get x squared minus 5x plus x minus 5. That's first, outside, inside, and last. You should know how to do the full method to multiply two binomials together to get exactly what you started with. So if I add those like terms together, again, this is just the checking part. I see that I do come up with exactly what I started with. So my answer of x plus 1, x minus 5 is correct.